Number 9, identify each of the 4 quantum numbers and the properties to which they refer. Now we have 4 quantum numbers here. The question's obviously telling us that, but we should know that off the top of our head. So we got to ID each of them. So that's the principal, the angular momentum, the magnetic, and the spin. But we also need to identify the properties they refer to. So we have N, the principal quantum number, referring to the main energy level. Okay, the average distance from the nucleus that electron or set of electrons inhabits. The angular momentum quantum number, represented by L, refers to the shape of the orbital. In the bright storm video that we saw during the notes, we saw that the s orbitals have a spherical shape, the p orbitals have a dumbbell shape, the d orbitals have, for the most part, a clover shape, and then that the f orbitals are a little bit too convoluted to actually represent with those types of shapes, but that shape is designated by the L value. The magnetic quantum number, represented by M, refers to the orientation of an orbital around the nucleus. So we already have the shape, right, because we already established that using L. And so for example, an s orbital, okay, an s orbital is spherical in shape. You can't change the orientation of a sphere around a nucleus because it's completely symmetrical. It doesn't matter if you quote-unquote shift the sphere anywhere, it's still spherical, and that shape remains unchanged. However, when you get to the other orbitals, for example, a p orbital, the dumbbell shape, you can have those p orbitals, and again, there are 3 different p orbitals. One of those p orbitals, one of those sets of dumbbells can run in the x-axis, one of those dumbbells can run in the y-axis, and one of those dumbbells can run in the z-axis, right? 3-dimensional coordinate system referring to x, y, and z as the 3 dimensions. And you're simply going to take the shape and move that shape around in 3-dimensional space until you get the farthest apart from each other that those orbitals can actually get. Then lastly, the spin quantum number indicates the fundamental spin state of an electron in an orbital. Now the spin state is pretty simple. You can either have upspin or downspin. Those are the 2 fundamental states. Numerically, that's represented by positive half and negative half, aka upspin, downspin.